Hello and welcome to Finance World. In this video we're going to continue the topic of quadratic equations and we're going to explore the second method of solving these equations. Now, I know it might seem to overcomplicate a problem, but we're going to borrow a basic concept but taken from economics which will make things easier when we have more complex examples. So let's try and relate this to a real life problem. And suppose you are at a food festival and you are selling fish and chips at a market stall. The cost to rent the stall is £500 per day for 2 days, and it costs you £2 to make each portion. So you prepare enough portions and you expect to sell 1,000 portions. We now need to set the price per portion. Now we can make a demand function, which is an estimation. That's also a linear equation that relates the quantity Q to the price P. Now, the coefficient of the price X needs to be estimated. So we have Q is equal to 1000 minus X times the price P. Okay, how do we go about doing this? Suppose you set the price to be £1 per portion. You'll probably sell 1,000 portions very quickly, and it's unlikely that you're going to cover the costs. And so we also need to estimate a maximum price per portion where you expect to sell 0 portions because the price you have set is just too expensive. Let's assume the price of this expensive portion is £10 per portion. So we can rewrite the above equation by setting Q equal to 0 and the price P is equal to 10, and we can have 0 is equal to 1000 minus 10x. Now we can solve this, which implies x is equal to 100. Okay, that's great. So now we have a demand function which relates quantity Q to P, the price, and this is Q is equal to 1000 minus 100p. Okay, now we need to find the optimal price to sell off a portion of fish and chips. Now, revenue is the quantity of the portions sold multiplied by the price P. This is just simply multiply the above demand function by P to both sides and you arrive at 1000p minus 100p squared. Okay, let's now define a profit as the revenue that we've just obtained minus the cost. Now, for simplicity, let's just model the cost as the cost to make each portion, and that's £2 multiplied by the above demand function. Okay, and let's also consider the cost of the rent of your market stall for the 2 days. So we now have 1000p minus 100p squared, that's the revenue, minus 2 multiplied by 1000 minus 100p, that's the cost, minus 1000, which is the cost of rent. So we can multiply out the brackets and collate all the like terms together to arrive at minus 100p squared plus 1200p minus 3000 is equal to your profit. That's great. That's a quadratic equation. And now we should find first the minimum price. So we can set the profit is equal to 0 such that the revenue you earn covers the total cost of preparing the portions and the rent. And we can solve this for P. First, you set profit is equal to 0 and divide the above equation by minus 100 on both sides. We now have P squared minus 12P plus 30 is equal to 0. Now, by inspecting this, you can now see it looks quite difficult to factorize. For you to try and find two integers that multiply up to make 30 and the sum of those two integers to equal negative 12 is quite difficult. So that means we need to aim for completing the square to find a solution. This is the second method of solving a quadratic equation. But first of all, let us first formalize the definition of a complete square. So, a perfect square is such that when an integer is multiplied by itself and it's written out explicitly, we obtain another integer. So, illustrating this with numbers, we could say 2 squared, which is equal to 2 times 2, that is 4. And similarly, if you took minus 2 squared, you have minus 2 multiplied by minus 2, and that's also equal to 4, because a negative number multiplied by a negative number is a positive number. So if you observe closely as well, if you take the square root of the number 4, you actually have two solutions, which is positive 2 or negative 2. Now if we extend this concept of a perfect square to an algebraic form, let's say we have x plus 1. Now if you square that, you have x plus 1 all squared, which is multiplying the same thing by itself. Now when you expand the brackets, you end up with x squared plus 2x plus 1. That's interesting because when you've squared an algebraic function, it looks like a quadratic. That means for any given arbitrary quadratic equation, you can actually write it out in the form of x plus p all squared plus q. First, you should identify that when you multiply out x plus p all squared, the above equation becomes x squared plus 2px plus p squared plus q is equal to 0. Notice you have an extra term here, and that's p squared, so we must account for this by removing it and taking away p squared. That means this expression, x squared plus 2px plus p squared minus p squared plus q is equal to 0. Note if you relate this back to the example we were given just before, is x squared plus 10x plus 6 is equal to 0, you should notice that 2p is equal to 10. That's just relating the linear coefficients together. Solving this, you will have p is equal to 5, and we can proceed with completing the square. Now, that means we can rewrite x squared plus 10x plus 6 is equal to 0 as x plus 5 all squared minus 25 plus 6. Remember, the minus 25 is there to account for the positive 25 when you multiply out x plus 5 all squared. So when you collate the constant terms together, you end up with x plus 5 all squared minus 19 is equal to 0. This is called completing the square. So we can go ahead and solve the above equation, and you can obtain x is equal to minus 5 plus or minus the square root of 19. Recall that the square root of a positive number has two solutions. Okay. Next, we will look at completing the square where the leading coefficient is not 1. And then once we do that, we will finish the fish and chips market stall problem as well in the next video. So there's more to come. We will aim to finish the topic of completing the square in the next video. We'll also look at deriving the quadratic formula, and we're going to inspect the discriminant, which is part of the quadratic formula once we derive it. We'll also take a first look into geometry, because we would always like to see what are these equations actually mean when you draw them out on a graph and you can visualize it pictorially. We'll then have a look at angles and the concept of trigonometry. It's a very fundamental and important concept of mathematics. Following that, we'll have a look at calculus, an applied branch of mathematics focusing on looking at curves on graphs, and we'll look at deriving tangents to these curves from first principles, and by looking at infinitesimal calculus, or differential calculus as you call it. That means that once you can draw a tangent to a curve, you can actually give that tangent an equation in the form of y, which is related to x of some way. Okay, so I hope you've enjoyed this video. If you did, please like and subscribe, or leave a comment down below if there's anything you're unsure of and we can discuss this further. If not, please stay safe and peace out.